In this video, we will see some important formulae in complex number जो कि सवालों में यूज करेंगे. तो फर्स्ट फार्मूला इज अ डिस्टेंस फार्मूला. डिस्टेंस formula. So this is A point and this is B point, and Z1 is the complex number, and here ZB represent the complex number Z2. So the distance AB is equal to modulus of Z1 minus Z2. Second, section formula. Section formula internal division. Suppose this is A point, this is B point. Z1 complex number represented by A point, Z2 by B. Suppose P is any point which divides this in the ratio internally in the ratio m is to n. So we multiply by m to Z2 and multiply n by Z1. So the complex number Z will be mZ2 plus nZ1 upon m plus n. If it is external, division is external, then Z is equal to m Z2 minus n Z1 divided by m minus n. See here, this point is A Z1. This point is B complex number Z2. This is P Z. The ratio is m is to n. Externally divide in the ratio m is to n. So the formula will be m Z2 minus n Z1 upon m minus n. And the midpoint, if we want to find the midpoint, third is a midpoint. It means here this is A point and this is B point. The Z2 complex number is represented by, so let this be the midpoint. Then the midpoint means 1 is to 1 ratio. Therefore, complex number Z will be Z1 plus Z2 upon 2, like in coordinate geometry. Here we can see this is 1 and this is a 1. Now, in the previous, we can see here m is to n ratio means this length is m and this PV is equal to n. And here, when it is externally, it divides externally, then this is n, Pn is n, and AB, A to this, A to P to M. This is a n. So this is the external division. Now this is the midpoint. Now the fourth formula is the centroid of a triangle of triangle ABC. If Z1, Z2 represent the vertices, let Z1, Z2, Z3 represent the vertices of a triangle ABC. Now see, to the centroid G is the point of intersection of medians of the triangle. So the formula will be Z will be Z1 plus Z2 plus Z3 upon 3. Now the next is some condition for quadrilateral. This is the fifth formula. We construct a parallelogram. Let this be A, B, C, and D are the vertices of the parallelogram, and this is a Z1 complex number, Z2 complex number, Z3 complex number, Z4 complex number. Now see here, this is a AC diagonal, and this is a BD diagonal. The diagonals bisect each other. Diagonals bisect each other in a parallelogram. Therefore, let this point be P. So midpoint of AB AC is Z1 plus Z3 upon 2. Midpoint of BD geometrically BD is again P. So let this be Z. So this is Z, and this is midpoint of BD is Z2 plus Z4 upon 2. It is also Z. Therefore, from these two results, we can see Z1 plus Z3 is equal to Z2 plus Z4. Suppose the geometrical figure is rhombus. These sides are equal and parallel. Therefore, again, we get the, suppose this is Z1, Z2, Z3 complex number, and Z4 complex number. So in case of rhombus, the condition will be again same, Z1, Z3, Z1 plus Z3 equal to Z2 plus Z4. Number one condition. The second is modulus of Z1 minus Z2 is equal to modulus of Z2 minus Z3. So distance means the side. AB is equal to BC. Two sides are same. This is the condition for the rhombus. Now see in squares. Now we will see here the square. Now see, this is a 90 degree. Now see, the conditions are number one, like the parallelogram shows, this is Z1, Z2, Z3, Z4. Now Z1 plus Z3 is equal to Z2 plus Z4. Condition number one. Second, modulus of Z1 minus Z2 is equal to modulus of Z2 minus Z3. Third, modulus of Z2 minus Z4 equal to modulus of Z1 minus Z3. Z1 minus Z3 means AC is equal to, BD. These lengths are equal, means AB is equal to BC. And BC is equal to Z1, Z2 means AB is equal to Z2, Z3. AB is equal to BC. So these are the three conditions we must remember in the squares. Now the eighth, in case of rectangle, angles are of 90 degree. Number one, opposite sides are equal. AB is equal to BC. AD is equal to BC. And diagonals bisect each other. So let this be Z1, Z2, Z3, Z4. Now see, first point is Z1 plus Z3 is equal to Z2 plus Z4. Number one. Second, AB is equal to DC, means modulus of Z, the diagonals bisect each other, means Z1, these diagonals are equal. Z1 minus Z3 is equal to modulus of Z2 minus Z4, means AC is equal to BD. These are the diagonals. So these are the two conditions, sufficient conditions for the rectangle in complex numbers. Now see the next point. Suppose this is origin and suppose in the anti-clockwise direction this is theta and this is theta 1. Now see, this point is Z1, this point is Z2. Therefore, here complex number Z1 is equal to R into e raised to, this is the polar form, and we convert this into Euler form. So this is equal to Z1 is equal to R into e raised to power theta, and Z2 will be R into e raised to the power iota into theta plus theta 1 is equal to r into iota theta plus iota theta 1, which is equal to r into iota theta into e raised to power iota theta 1. Therefore, Z2 is equal to Z1. This is Z1 into e raised to power iota theta 1. So we get this result. Rotation of the complex numbers. Second, suppose this point is O and this is Z0. This point is Z1, this point is Z2, and the rotation is like this, theta 2. So this distance will be modulus of Z1 minus Z0, and this distance will be Z2 minus Z0, modulus of this. So this is the given to us, and we are to find this. Now we get this Z2 minus Z1 Z0 divided by modulus of Z2 minus Z0 is equal to Z1 minus Z0 divided by modulus of Z1 minus Z0 to e raised to the power iota theta. Theta is the angle is. So this the rotation is in anti-clockwise direction. Rotation in anti-clockwise direction. Suppose rotation is in clockwise direction. Means this rotation is like this. This is Z1, this is Z2, and this point is a point of rotation. So the formula will be Z2 minus Z0 divided by modulus of Z2 minus Z0 is equal to Z1 minus Z0 divided by modulus of Z1 minus Z0 into e raised to the power minus iota theta. This distance is modulus of Z2 minus Z0. Distance between the 2 points, and this is a Z1 minus Z0. The distance between this is A, this is these are some results we see here. Now we want to know some equations, geometrical figures. For example, equation of the circle. Equation of circle in the complex numbers. How to derive the equation of circle? Let this be the center of the circle, and P be any point on the circle. Center is represented by Z0 complex number any fixed point, and z be any complex number whose locus is on the circle and the radius is r. Therefore, modulus of z minus z bar is equal to r. Distance is r. This c is center and r is a radius. Now see, squaring both sides. Squaring both sides, we get modulus of z minus z naught whole power 2 equal to r square, which implies z minus z naught into z bar minus z naught bar is equal to r square. Open the bracket. Z into z bar minus z into z naught bar minus z naught into z bar minus z naught z bar, and transfer this to the left side, we get this. Let this z bar is equal to minus alpha. So this equation becomes z into z bar plus alpha z. This is constant complex number. Now this becomes alpha z plus alpha z bar. Here z bar into z bar is z into z bar is this, z into z bar this, second term z bar into this, minus minus plus this, plus z bar into z naught. So minus minus plus, so this will become minus modulus alpha square minus r square. So this minus minus will become a plus, which is equal to 0. Now let us suppose alpha modulus alpha square minus r square is equal to c. C belongs to the set of real numbers. Now this equation becomes z into z bar plus alpha z plus alpha z bar plus c is equal to 0. Therefore, radius will be, from here we get under root modulus alpha square minus c. So this is the radius of the circle. This is the radius of circle. So this is the required equation of the therefore equation of circle is z into z bar plus alpha z plus alpha z bar plus c is equal to 0. Here center is minus alpha and radius is equal to square root modulus alpha square minus c. Equation of line. Equation of line. The general equation of a line is the general equation of line is ax plus by plus c is equal to 0. That z is equal to x plus iota y. Therefore, x is equal to z plus z bar upon 2, because z bar is equal to x minus iota y. If we add, we will get 2x, and we divide by 2, so we get x. This is the real part, x. And if we subtract this, we get y is equal to z minus z bar upon 2. We will get free of, this is upon 2, free of iota, so we have to divide by iota. So if we add these two, if we subtract, x will cancel out, iota y plus iota y. 2 iota y we have to divide by 2 iota, so we get y. Now put the values of x and y in this one equation. Put x, y in 1. We get here a into z plus z bar upon 2 plus b into z minus z bar upon 2 iota plus c is equal to 0. Now that is a upon 2 into z plus z bar plus b upon 2 iota into z minus z bar plus c equal to 0. That is, if we take z common, so we get a upon 2 plus, here b, here there's b, upon 2, a upon 2 plus b upon 2 iota plus z bar into a upon 2 minus b upon 2 iota plus c is equal to 0. Now further, see here, if we multiply by I and I, b upon 2 iota multiply I upon I, we get minus b upon 2 minus b upon 2 iota. So here we can write z into a upon 2 minus b iota upon 2 plus z bar upon a upon 2 minus plus b iota upon 2 plus c equal to 0. That is z into a minus b iota upon 2 plus z bar into a plus b iota upon 2 plus c equal to 0. Now let us suppose a plus b iota upon 2 is equal to alpha constant complex number. Therefore, this is the conjugate of this, so this equation becomes z into alpha bar plus z bar into alpha plus c is equal to 0. So this is the equation of line. This is the equation of a line in complex numbers. Now see slope of the line. Slope of the line will be is equal to minus, formula is minus alpha upon alpha bar. This is the equation of the line. Let this be a mu. So this is the slope of a line, and this is the equation of the line, the complex numbers. So this result is also, we can understand the equation of line by deriving this equation from the general equation of the line, where a, b, c are the real number, x, y are the general point on the line. So general equation of the line, jx plus by plus equal to